Okay, hello everybody. Thank you for coming. This is the Big Data panel, and we've got a distinguished group of speakers here that I'll ask to introduce themselves. Let's start with Vicente over there at the end and work our way to me. My name is Geva Perry. I'll be moderating this panel, and I'll let the panelists introduce themselves. Please tell us a little bit about yourself, your company, what you do, and kind of your perspective, where you're coming from to big data, because some of the folks we have here are vendors, some are more enterprises that use big data. So give us your take on it,
Sure,
where you're
great.
coming from.
My name is Vicente. Good morning, everybody. It's great to be here. I work for TOTVS, TOTVS. It's probably the largest company that you guys have never heard about it. And that's because we do business primarily in Latin America, more focused in Brazil. Pretty big in Brazil and Latin America, work in 10 specific verticals from agriculture, retail, education, finance, etc. And here in Silicon Valley, we have TOTVS Labs. And the goal is to find great companies to help our existing customers in Latin America. So I'm here today to find nice companies from maybe Israel that can help them to enter in a new market in Latin America. I can help by introducing to my customers or even investing in companies. Our take in big data is more to help our customers to solve business problems. Because our customers, they are mostly mid-sized or small companies. They have no idea what big data is. They have no idea of what Hadoop is. And they probably will never have Hadoop installed on their company. So we want to help them to use big data technologies, but to solve nice and real business problems in different sectors. For example, what I just mentioned, education, agriculture, manufacturing, retail, supply chain, etc. So that's our big focus on Good Data today, how to help companies to solve business problems.
Thanks, Vicente. And we'll touch on that a little later about the different applications people are using big data for. And just so I understand, in your company, you do use Hadoop and other big data technologies?
We don't. We don't use it. Just a disclaimer, I'm an investor in a company called Good Data. They're based here in San Francisco. And besides an investor, we are also a customer. So what they provide is an end-to-end big data platform and analytics. So I don't need to install a Hadoop. I don't need to use it. I use everything in the cloud. I have all the data there. And that's how I'm using big data today.
Got it. Thank you. Neil, why don't you introduce yourself?
So my name is Neil Mendelson, and I work for Oracle. I'm in development, and I'm responsible for big data and predictive analytics. Oracle's, I guess, to begin with, when we look at big data, we think of the definition not being exclusive to Hadoop. We think of it more in terms of the way Facebook and others are defining it today, that it's more of a platform, and those platforms involve multiple technologies like Hadoop, NoSQL, and relational. And we're producing products, both hardware and software, all the way up and down the stack, as well as looking to reach out to many partners that build applications in this space to really help our customers, rather than just getting technology, to really have an application that they can move forward with. So we're just seeing this kind of take off around the world, in pretty much every sector. Over the last few years, it's been a lot of experimentation, right, which is most of what's been going on. And now we're seeing some real moves where people are really investing, companies are really investing with specific use cases in mind, either CX, which is a really big area that people utilize big data for, in cyber and security, another area that people do a lot with. We also see kind of the standard IT kind of data warehouse modernization, where they're adding big data or into that mix as well. And then we see companies that, new and old, that are essentially establishing data as their business, right, and using a big data platform with that. And as I say, we sell it ourselves and use it internally, and it's been kind of an interesting ride, and I think we're just going to see that continue to accelerate as an industry.
Great, thank you, Neil. Nati, why don't you introduce yourself?
Yeah, so my name is Nati Shalom, the CTO and founder of GigaSpaces, and among all things, close friend to Geva, who I know from GigaSpaces, but we remain very good friends. One of the things that I think we've done in GigaSpaces for quite a time is actually produce a lot of entrepreneurs beyond the actual product. I think I've counted last, it was roughly 15 entrepreneurs. Some of them are in this room, some of them are in this valley, some of them somewhere else. That's something that I'm personally proud of. Out of a company of 70 people, I think producing at least 15 entrepreneurs, Israeli entrepreneurs, is a big success in my view. From a big data perspective, we've been dealing with big data starting from 2000, I think that was, primarily around HPC at the time. And today we're doing two main things around big data. One of them is high performance, big time analytics. And in that context, so one of the things that we're doing is high performance analytics using memory, using flash disk today. We actually announced a new flash integration. Basically means how do you basically process more data faster at a lower cost. And on the other hand, we do the data management. How do you actually orchestrate big data? How do you run it on premise? How do you run it on a cloud? How do you automate the deployment? How do you integrate a lot of the products that you have? Those are the two main problems that we're dealing with today.
Right, and we'll get into a little later the different, because big data is a very broad description. It actually means a lot of different things, and we'll get into some of that not all big data is made the same. But let's go on with the introductions.
Good morning, everyone. I'm excited to be here. My name is Alan Kamer. I am the Chief Commercial Officer for a company called Optum in their division called Optum Analytics. Optum is a roughly $40 billion division of United Healthcare, and we're part of the organization that provides analytic tools and services to the healthcare delivery system, and we service the healthcare providers, so major hospitals, medical groups, integrated delivery networks across the United States. And I am one of the co-founders of a company called Humedica that United and Optum acquired just under 2 years ago. And our work with big data is around healthcare information, and particularly electronic health record data, and integrating that with claims data and other sources of information. We have nearly 50 million lives of patient-level data coming out of electronic health records from several hundred hospitals and several thousand clinics across the United States. We use that information to deliver a cloud-based software-as-a-service application and set of tools and products back to the providers so they can better understand where there are opportunities to improve care and better achieve cost-effective outcomes with the information. And since we've joined Optum, we've been increasingly integrating our data with other data sources, and there's a huge set of information that's coming in related to the healthcare of patients that providers are looking for us to integrate to have a better picture of how their patients are performing and how they're doing with the treatment of their disease when they're not in the doctor's office.
Thank you, Alan. Mark.
Last but not least, hopefully. My name is Mark Kraynak. I'm from Imperva, which is a cybersecurity company focused mostly on application and data security. So I actually come to big data from 3 points of view. At Imperva and a company I work with called Exabeam, we use big data techniques to deliver security. So Imperva uses big data to deliver some of our security services. Exabeam is really building a big data analytics platform for security. My role at Imperva is Chief Product Officer. And prior to that, prior to Monday this week, I also included marketing. So we're not quite big enough to need the big data part of this, but predictive analytics for marketing is something I've been looking into for a while. Has some interesting challenges there. And then finally, as a security vendor, big data.
From a user point
From a
of view.
user perspective, me as VP of marketing looking at how to do better lead gen, essentially. And then as a vendor of security products for data security, a lot of my customers are asking me to secure or help them figure out what they're going to do for security for their big data environments.
Great, thank you very much. So, just so you know, we all know, we've all heard big data. It's a very, it's a buzzword we hear a lot. Just to give you some sense of it, according to IDC, in 2011, the world created 1.8 zettabytes of data. That's 1.8 trillion gigabytes. That was in the beginning of this decade. by the beginning of next decade, it's going to be 50 times that per year. So we obviously have huge amounts of data, and there's a lot of value to create from that data. So we can, and some of the speakers here mentioned, you can create a lot of value, optimizations, business value, etc., from this value, from this data. Just to give you a sense, and Alan, I'm sure, is very familiar with this number, McKinsey did a study where they analyzed what the impact of taking advantage of all the data that we have, if we really took advantage of it, what would be the impact of that on business? So for the US healthcare industry alone, McKinsey believes that could create $300 billion in value annually. And they go on to talk about some other industries, for example, the retail industry, marketing. I mean, there are a lot of different areas, security, some of the areas that have been mentioned here, where actually utilizing this big data could create a lot of value. So my first sort of question to the panel is, if all this value can be created, what's stopping us right now from making it happen? What are the barriers, challenges, if any? Maybe the answer is it is happening. But what do you think, if it's not happening in a big way, why do you think it's not? What are the main barriers for us to take advantage of big data? We could go in order, or let's go in reverse order this time.
So I think vendors have it easy, because if you're having like with Imperva, the systems that we're using big data for are sort of behind the scenes SaaS offerings. So we can create something, put data in there, play around with it, and then when it's ready, deliver it to the market. So today we're delivering a lot of value. Our threat radar, reputation services, and community defense are built on MongoDB, which we chose mostly because of scale, not because of detailed analytics or anything like that. In my customer base, what I see the problem is they don't have the skill set. It is a big change for them to go from essentially relational databases to something else. And they're all interested, and they're all learning, and it's taken a while to learn.
So in healthcare, particularly with the provider market, I would say that...
Alan, just quick, that number, that $300 billion number, I'm sure you've heard it before, right?
Yes.
That
yes.
McKinsey study is often
That's
quoted.
well known in the industry, and I would...
What do you think? You have an interesting perspective on it. I mean, you're right in there in the trenches. What's the...
Yeah, so no doubt there's a huge demand and huge opportunity in healthcare, and a lot has changed in the last several years. I think there have been two major barriers that have prevented widespread adoption of healthcare big data and analytics. The first was for those organizations that had healthcare IT systems, electronic health records, billing systems, et cetera. Everyone bought best-of-breed systems, and none of those systems would actually speak to one another. So you had lots of data, but lots of data siloed and really not able to be integrated and looked at cross-system. So even a singly owned system that had dozens of hospitals and clinics, they couldn't tell you from hospital to hospital, clinic to clinic, some of the challenges that they were seeing as an organization. Companies like ours, when we started...
It's an age-old problem,
yes,
data silos. No?
Age-old problem, and companies like ours in 2008 began to solve that issue and began to make data more accessible and able to be interactive with one another. I think another major driver of the change going on in healthcare is certainly the Affordable Care Act, the Obamacare, as many of you know it, which is not only laid the plumbing and created incentives for those providers that weren't even on electronic health records to do so, but also is really transforming what requirements are going to be necessary in order to get reimbursed by the government for the care that they're being delivered. So as a result of that, we're starting to see a huge transformation, really the healthcare delivery systems. And
not a lot of people know about this. A big part of Obamacare is, besides all the insurance stuff and all that, is electronic record, medical electronic records, like standardizing that nationally, right?
Creating requirements around things like meaningful use and reporting of clinically relevant information, not just billing code, but how medicine's being practiced, in order to get reimbursement from CMS or the government entity responsible for Medicare and Medicaid. And that's coming. It's in its infancy now, and the requirements are growing over time. But providers' reimbursement are suddenly being challenged in ways, and the need to be able to report and produce information and understand what's going on with the populations that you're responsible for and treating is increasing significantly. Additionally, the reimbursement system, many providers are finding that insurance companies, payers, not just the government, though the government has experimented, are going towards a fee-for-value model. So moving from volume, fee-for-service, where each time a patient came in, they would be treated and paid, to a value proposition where a provider would have to go at risk for the outcomes associated with that patient. So if you are treating a heart failure patient in a hospital and that heart failure patient is discharged and that patient comes back within 7 days as an example, you would not necessarily now get reimbursed or paid for that second visit of that patient. So providers need information to manage the risk that they're now undertaking with patients. So I think those two things are driving an accelerated adoption of big data and analytics in healthcare.
Accelerated adoption, but the barriers are the data silos is what you're saying, the integration of all these systems.
Absolutely, absolutely. And the investments that had been made in previous years in healthcare IT have typically trailed other industries and have lagged as well.
All right, Nati, what's your perspective? What are the big challenges?
First of all, I agree with the data silos. I think that there are two kind of silos beyond that. There is also organizational silos, because one of the things, I think in many ways you could look at what happens in big data and back to your question was, there is a lot of business value out of big data. Why are we not capturing
Potentially.
it? Potentially, yes. And why are we not capturing it? So if I kind of try to take the reversal of that question, I think that in order to capture the value, what do we need to actually capture a value of big data? And what we need is very similar to DevOps, right? It's a holistic view of all the data that we have, let's say the customer data. And even let's take the customer data that is visiting our website in marketing tools. So we don't need it to sit in Google Analytics as an anonymous data, and then we have Salesforce in which we actually have a name behind it, and then we have other tools, each one of them taking pieces of the data of that customer, but it's very hard to have that 360-degree view of that customer to say, this is the valuable customers, he's having problem, he's not having problem, he's visiting our website, and we're seeing that he's actually losing sight of what he's looking for, he's not experiencing well the product, and so forth. So in order to get to the point where we can actually have all that integrated information, we also need to look at the organizational structure. And right now, there is, for example, a new title that is called Data Analyst, and Data Analyst is supposed to make sense of that data. But usually the data analyst sits somewhere else and is not connected to the people who actually develop the application and knows what data they produce. And they can potentially produce even data that makes more sense from an insight perspective if someone will tell them, well, by the way, if you'll add that logging or that element into the tracking information that you're adding, I could make more correlation, or much better correlation, and I could make much more sense for the data. So we're seeing also a culture change that needs to happen in the organization, because they now need to look at those insights from a holistic perspective and need to reorganize the group, not as data scientists, developer, application that are doing their stuff, but actually a group that are very much built out of the business. And the data scientist, for example, needs to be part of that group. So that's one challenge. There is obviously, I don't want to take the time to describe that there is a lot of technical challenges of moving from the old system into the new model of systems.
We'll get into some technical aspects a little later.
Yeah, so I don't want to dive into that. I wanted to really focus on the cultural challenge that I think comes with that as well.
I mean, one of the things we're seeing repeatedly, again and again, in every survey they do of enterprises, what's your biggest challenges in big data, one of the, if not the number one, but certainly top 3 issues is the lack of big data expertise in the organization. That's a big challenge that, you know, some of it can be solved technologically, but some of it really is culturally and it's a sort of a society problem. But it touches a little bit on what you're saying. Neil, what's your perspective on the challenges of big data?
So we kind of see 3 themes repeated by people that we talk to on an ongoing basis. The first one we've talked about, which is skills, right? There's an existing skill set that exists within organizations, and they know how to query data, they know how to write applications and so forth. They generally do so through, some form of a SQL interface, but how do you get that interface on top of Hadoop, and how do you get that interface on top of NoSQL, right? The second one is the integration challenge, and the third really relates to security and governance, right? But back to the first one, if we think in terms of, just take an example in healthcare or other industries where you have your customer information, right? The medical records, if you will, that's stored in a relational database, right? And now what you want to do is you want to mix it up, right, with other information coming from other sources. Maybe it's coming from their Fitbit. Maybe it's coming from other medical devices that are now throwing off constant data, right? That data is more likely to end up in Hadoop, right? So now we end up having the classic problem of, stuff in Hadoop and stuff over in relational, and maybe you're capturing some of that information flying off in a NoSQL database, right? How do you bring that together, right? Classically, let's not forget that this is not our first rodeo as an industry, right? Data warehousing to a very large degree had a lot of the same characteristics at the time that we're talking now about big data. So there are a lot of lessons that we can learn. So one of the things that we spent a lot of...
In fact, Neil, I'm going to touch on that after this, that a lot of the projects that are so-called big data right now that people are really just data warehousing, ETL projects that we've always seen, just with more data.
Number one use case is ETL offload of data warehouse, right? So, the thing that we saw kind of begin to change in the industry about 6 months to a year ago is, trying to address this skill sets issue, right? I mean, how many people do you know that can write MapReduce? How many people that you know that can write, Pig Latin? How many people, have these skills in these new languages? How many programmers do you have that can write in, programs that access APIs in NoSQL? So what we saw was the emergence of the notion of SQL over NoSQL, right? Whether it be Cassandra or Mongo, and then SQL engines that are coming up on Hadoop, like Spark and other ones like that. So what we went off doing was we essentially created this thing that we call Big Data SQL. And the idea behind it is that you take the modern dialect of SQL that you have right now, and we're able to run that dialect against relational, NoSQL, and Hadoop all at the same time, right? You don't move the data, right? We push down the processing to the Hadoop nodes or to the NoSQL nodes directly, right? And we process the data closest to where the data exists, right? And then we bring it back and join only that small amount. So what it's doing for our customers is all of a sudden, if they want to be able to get access to information in NoSQL, they don't have to dump it out, right? They can just access it natively, and they don't have to write programs in MapReduce or other things like that. In Hadoop, they can just use SQL, right? So I think from an access language point of view, that's something that, certainly from our customers really begins to address the skill set.
So what you're saying is, and of course Oracle isn't the only one who's doing SQL on Hadoop or just giving, so there's traditional skills that are very common actually, which is knowledge of SQL. But we're sort of taking these back-end technologies that give us new big data capabilities, and we're putting on top of them an interface that uses the very familiar programming skills.
Yeah, the difference being is that what's emerging now is silos of SQL, right? So you have a SQL engine on Hadoop, which is not a full SQL engine, but a partial SQL engine, but it can't talk to NoSQL, right? So it can only talk to stuff on Hadoop. And then you have SQL projects on...
things like Pig Hive, those kinds of things.
So you have, and things like Impala, Hadoop-only engines. And then you have projects, Cassandra has a project, SQL over that, over Mongo as well, where it can only query data in NoSQL, right? But the reality of it is that any one of these systems is likely to hold data in any one of these three systems. And do you really want to be moving the data around? What we want to do is we want to push the processing down to these systems, right? Use the skills that we have, right, in order to accelerate the market forward.
Follow-up question. I mean, what do you lose, though, when you layer SQL on top of something that fundamentally wasn't necessarily built to be relational like SQL was built for? I mean, is there a use case that you can't address or some compensation you have to make for it?
See, I think one of the fallacies that people think of is that, while SQL was born with relational, right? I mean, they came together, right? SQL has evolved tremendously over the years. It was more than 15 years ago that SQL was modified to be able to talk to XML, right, which is semi-structured data, and to be able to talk to unstructured data. I mean, Oracle and IBM, frankly, worked together for many, many years and competed in the market to evolve the SQL language beyond that of structured relational. It's been that way for many years. And largely what you lose is a lot of high-price programmers, right, and you use your existing resources, right? So, there are certainly use cases where, a specific engine could maybe run a little bit quicker. There's no question about that. But, what we're trying to do is to try to, bridge that gap, right, between where we are and where we want to get to.
What we have seen in the market, what the industry is not adopting as we would like to, especially the vendors, right? Actually, I think the technology is in place. It has evolved a lot. Like servers, it's much cheaper today for you to store data. Things that in the past would take like hours or days to process, now you can process extremely fast. One of the reasons, I guess, that businesses are not adopting even more big data technologies is because we are, can you guys, okay, can you guys hear me now? Cool. One of the reasons is the silos, right? We are not democratizing data just yet. And that's one of our main missions. We want to make data available across the business, across your company. So the data that the marketing scene is the same, that the sales team is seeing, is the same that the people developing the product are seeing. So that's what we want to do. I think there is people remember in the past where we had these silos of data, or maybe to get a new report, to get a new dashboard, take months and months of project. You would have to buy different products, different ETL, different technologies. And eventually, when we get the data is already old. It doesn't make any sense for you anymore. So I think now we have the technology, but it's our mission now to democratize this data, to make this data available across the company.
Okay, thank you. Are these mics working, by the way? Because I can't hear it. So you were actually saying, Vicente, this is a good sort of segue to what I want to talk about next. You're saying that technology is there, but actually I think one of the challenges people are having is that there's almost too much technology and it's happening too fast.
I agree. It's too much noise, actually.
So I'll give you one example, a startup that I've worked with that they came up with a product, they haven't released it yet, that was built on Hadoop. And before they even released the product, they scrapped it and released a version 2 using Spark, because that's the new thing now when everybody's using Spark, because these things are moving so fast. The other thing I'm hearing a lot from people is there's a lot of confusion. If you want to sit down and let's just take Hadoop, and I realize, I don't mean to offend anyone on the panel, Hadoop isn't only, big data doesn't mean only Hadoop, but let's just take Hadoop. It's such a confusing ecosystem with new technologies and projects coming out every day almost, it seems like. People just don't know how to begin even. So maybe a perspective on that. Nati, you were saying to me before the panel, maybe you go ahead and kind of give your perspective on how should we think about all these technologies that are out there? How should we classify them?
Right, so I think that that's actually a very complex question, and I'll try to give a simple answer to that, and I will borrow some of the things that I've seen from GigaOM when they analyze that. So GigaOM draw 2 axes to describe the trends, and within that trends you could see different solutions. One of them is solution that are optimized for volumes and solution that are optimized more for performance, velocity as it is called. And what we could see over the years is that we started with the least common denominator, which was relational database, which was trying to cover everything. So it was kind of the least common denominators. It was trying to be good in analytics. It was trying to be good in transactional data and do all those type of things. That was good as long as the volume and performance requirement wasn't too extreme. Over the years, the volume and performance requirement moved quite by an order of magnitude higher, which means that this least common denominators cannot meet either of those axes, neither the volume or the performance. And so we started to see solutions that are either optimized for performance or volume. So for example, Hadoop would be on the volume side, less on the performance side. And a lot of the batch analytics, ETL, would fit into the solutions that are optimized for processing high volume of data. On the high performance side, you'll see at the very extreme in-memory solutions, stream-based processing like Spark that are emerging, and those solutions are mostly trying to deal with continuous updates, for example. Something that, for example, if you're collecting a lot of data from a lot of sensors, like you do with IoT, you have to do a lot of updates. So obviously doing a select for update or something like that doesn't make sense. So you have to do an incremental updates, and that brings a completely new paradigm on how you do continuous updates. And that's where stream processing comes into place to address that problem. In-memory
so you're
solution,
saying one first distinction, we have to start kind of realizing not all big data projects are the same.
Right.
They have different needs and so on. One classic one is, batch versus streaming
yeah.
type of analysis. And there are other things that are more performance sensitive,
Yep.
things that are just very large volumes that we need to somehow find ways to process them very fast in batches, that kind of thing.
Right, exactly. So I think that there is the volume batch processing, which is Hadoop research. There is high performance, which is stream processing, in-memory databases. There is a new kid in the block here, which is Flash, which is actually kind of pushing the limit in terms
Flash?
of Flash,
Flash
yeah,
memory.
Flash-based devices, which is actually pushing the limits in terms of what you could do between performance and volume. So you could actually push the volume and performance to a higher degree. And there is always also things like object graph, which are more dealing with social, like friends of friends, and how do you find query of friends and do those type of analytics. So object graph would be very much optimized for that. The bottom line is that each solution have a sweet spot, and there isn't one solution that covers them all. And that's why you see the emergence of those different solutions. And a typical solution would be any big data architecture that you'll have today would probably look like Hadoop for doing all the aggregation of all your data. In the front end, you'll have something that will be more transactional data. You'll have caching as part of that. You'll have stream processing as part of that. And all will be sending that data back to Hadoop. And that becomes an integration problem, also an operational problem. How do you manage all those different solutions, and how do you integrate them, especially when we're talking about the silo that Alan was mentioning. That becomes, in my view, the next challenge.
So I think one of the, and I'll do without the microphone, I think we make a mistake, right, as technologists to begin dividing markets by technology, right? Yeah, maybe grab a microphone because we're recording ourselves. So I think we make a mistake as technologists to begin dividing markets by technology, right? I think what we need to look at is the use cases behind it, right? Data warehouses were built, right, as the single version of the truth. They were built in order to be precise. That was the place where you do statutory and regulatory reporting from. Every answer has to be precise. And that's why the ETL that you do for a warehouse takes so long. Precision takes a long time. A lot of the use cases that we're seeing for Hadoop are not about precision at all. In fact, the warehouse was very ill-suited for marketing, right, as a line of business. They don't want precision. They want approximation, right? I don't need a precise answer.
The original use case, which came from Google, was one that didn't need precision.
Yeah. So I think that, looking at systems that are geared toward precision and systems that are geared toward approximation, right, that is really a better distinguishing set of characteristics than looking at these technology things like volume and velocity, because nobody can tell me, right, at what volume or what velocity one technology beats another technology, right? It's an abstract kind of a concept, right? On the other hand, what is the intended purpose of the system, right? You don't need the same kind of ETL on Hadoop if you're looking for approximation. What you need is machine learning that goes and looks over the data, right, and begins to classify and categorize the data, right, itself, so that you can then have either a business analyst from a democratization or I like to call them math guys rather than data scientists, because whenever I give somebody a title for a data scientist, I got to pay them more, right? So, like, okay, math major? Okay, all right, great. Data scientist, $100,000 more. Shit, okay. So,
That's probably the most useful thing to learn today is call yourself a data scientist.
Yeah, that's right. I actually have a friend that I suggested he change his title on LinkedIn, and his hit rate went up exponentially, as you might imagine. So anyway, but begin to look at it.
Well, that's marketing.
Yeah. Begin to look at it, not in these arbitrary technology terms, right? But look at it from a business point of view, right? Are you building a system of precision? Are you building a system of approximation? Do you look to join the two together for a specific outcome, right?
So I would take it from a different point of view, from the practicalities of what I see my customers struggle with. At the Hadoop layer, you've got, I don't know how many different distributions. Some of them have stuff that works across all distributions. Some of them have their own little thing that plugs in for whatever part. I think the most practical, and especially for enterprises who are usually doing a data warehouse replacement, I would say pick the most generic possible set of things and refuse to commit to something specific unless you have to for the use case. And wait, because if you have a specific requirement now and you don't find something that does it, 3 weeks from now maybe something will exist that will help you. So the longer you can wait to commit to something in a stovepipe or one of the distributions, wait if you can.
Right, and that's one of the things that's causing delay in getting the business value out of big data, because people are confused or waiting or not sure, don't want to take the risk and all of that.
Do you want to upgrade your iPhone now or wait to the S,
Well,
right?
if
it's
you
the
do-
same decision.
If you do have a use case that needs something specific, pick it, but then come up with a plan. If it goes away or if something better comes along, I think you should go into it with a plan of how you're going to deal with that. So that you, in that case, if you can't wait or you don't want to wait, you don't have to, but be aware that you're going to need to be agile down the road.
That's why I believe the focus should be the business problems. What are the problems we're trying to solve? It's a combination of complex algorithms, technology for hardware and software, but that should be the focus. We're not even going and chasing IT to sell anymore. We want to chase to business people. What are the problems I can help you to solve? Using algorithms and using maybe flash or storage technology, whatever. But what are the business problems that I can help you to solve? That I believe should be the focus. Then, if it is the iPhone 6 or 6S, that would not be that important anymore, in my opinion.
Did you want to add something?
I think that the thing that I wanted to add is that when we look at the business problem, I think that there is a relation between the business problem and the solution, because most of the solutions are targeted toward the business a business problem. And so when we look about real-time analytics, there is a business problem that we're trying to solve with real-time analytics, which is a real-time view and real-time actions on the activities of a user. And if we're looking at trend analysis of the past year, we're looking at EDL type of processes. So there is a direct correlation. I don't think that you could say that if you drive things through business and precision, that would help to categorize the solution enough. And I think that there is still a very high confusion, because most of the solution would try to preach themselves to do more than what they're actually built to do. And if you don't try to understand the sweet spot, because the sweet spot of each solution and which type of business problem you can actually solve, then it will be very hard for you to actually draw the right architecture. And what we'll see is that most people would take MongoDB, for example, and try to solve the universe with it, and fell on their face several times until they understand the sweet spots and what to do with that. So I think that classification, both the technical and business, are very highly correlated and very important, because there is a lot of confusion right now, and people are making a lot of mistakes right now in how they architect their systems because of that confusion, because they think that every solution can solve all the problem until they realize that they're not.
Right, and also there's trends and fashions in this industry. So I've already seen, I think, 3 or 4 times companies that have moved from a SQL database to Mongo because that's the cool thing to do, then realized, wait, actually SQL is much better suited for this type of job, moved back to SQL once the Mongo didn't perform. But so we're seeing that. You could do, no, but the problem was the actual, engine underneath that they were having problems with, that they needed a relational one. So there's a lot going on in terms of the types of projects of big data that are happening. And I think we mentioned before that even though there's all this talk about using big data for business, really a lot of the projects that are going on right now are very technical. They're essentially transforming data, ETL, essentially loading it to essentially a data warehouse, transforming and doing very basic stuff with it. I think that's the most use of Hadoop today. So other things are going on with big data. But on the other hand, we're seeing sort of the other end of it, which is business applications using big data. And we've got in healthcare, obviously. We're seeing stuff in security. We're seeing stuff in marketing, analytics, etc. What are you guys seeing in terms of what's the actual projects, the big data kinds of project you're seeing in real life? I mean, what's going on out there? Just anybody can, yeah, go ahead.
I can speak in healthcare. We have many of our providers are looking to understand their population, so using population health analytics. They want to know which patients are being undertreated. Let's say they have a chronic disease and they're not coming in regularly to see the doctor. They want to know which patients actually have the chronic disease, because a lot of times the information isn't recorded in structured data fields, so we need to apply natural language processing that's clinically targeted or focused to pull out and help them understand which patients have the disease. They want to predict which patients are going to end up in the hospital in heart failure, as we were talking about earlier, or which diabetics are going to develop chronic kidney disease. So taking all that information and being able to drill down to a clinical level, so a doctor can look and understand which patients fall into a range. In diabetes, they might have an A1C score between 8 and 9, which would suddenly mean this patient's getting much sicker, their costs are going to be greater, their needs for care are going to be more significant. You want to overlay comorbidity, you want to get down to the physician level and try and link back to which doctors are treating these patients, how are specialists doing compared to the primary care doctor? Are they achieving better outcomes once they get referred, or is the distribution look awfully similar to if a primary care panel was treating those patients? So really digging in to the...
This is way beyond just some technical projects with data. This is really, I'm not sure if in your case we could call it business value, but it's life and death value. Maybe.
Life and death value, and ultimately where we're being pushed is more and more at the point of care. So we start, our base application began as a monthly update on population health, so they could look across their pick your disease, hypertension, dyslipidemia, diabetes, et cetera, and look at these chronic diseases and look at the care and see where there are opportunities to improvement, to benchmark against not only internally, doctor to doctor, hospital, clinic to clinic, but also externally against all of our other customers. And now that's evolved to overlaying financial data and risk data, so you can quantify the dollars associated with those patients and build in predictive clinical and risk scores based upon their profiles. It's evolved to care coordination tools, so you can pick a cohort, create a registry, and follow those patients and understand what types of interventions are being done outside the doctor's office by care coordinators, what vitals are coming in, and integrating those data back in so you can better understand where your limited resources should go, which patients need to improve, and ultimately how to manage your populations and your workforce more effectively.
As a citizen, it's actually very comforting to hear you guys are doing this stuff. I'm surprised.
From a security perspective, a little different point of view, although in some ways pretty similar. Today, most organizations, when they're providing security for their environment, they look at what happens on their environment and they make decisions based on that information. But the opportunity to provide threat intelligence across organizations is huge.
It was based on strategic go, which are the most important.
Hey, we got a little bleed over from next door. Interesting. If you can look across organizations, so if I have 500 customers that are sending data.
Still haven't solved very basic technology problems.
That's right. To Imperva about the attacks they're seeing on their infrastructure, and we have to handle a huge amount of data. Even 500 customers worth of data on a daily basis is a huge amount. So that's a scale problem, not so much precision. We have some autonomous, some automated ways of analyzing that, some human ways, and then we republish that back out. So now you've got a much broader footprint. You can see that someone attacked that customer first, and by the time they get to you, you're already going to defend against what they're doing. So I think on that sense, from a security perspective, the raw scale is probably one of the easiest and most valuable things that big data brings.
And that's happening now because we're collecting, first of all, we've got so many devices and sensors and all these things going on, and we're collecting all this data all the time, and now,
they have to do something with it.
right.
I'll speak from an infrastructure perspective. I think that there are two categories of things that I'm seeing common across industries. One of them is the 360 degrees data. So there's a lot of projects of creating that reference data, if you'd like, from all those different systems, and a lot of projects that are actually
360 degree data, meaning like they have these projects 360 degree
like
view
for
of the
example,
customer,
view of the
things like that?
customer, view of the
Okay.
system, view of whatever. It's basically taking a lot of the data from all the silos and trying to put it in a place in which you could actually see that 360 degree in a simple way.
A picture, full picture.
Exactly, exactly. And I think that's, speaking to the point that we mentioned before, that's, I think, the biggest challenge, that in order to actually make sense of data and actually make business value of data, you have to cross that barrier to actually do that. And that's why I'm seeing a lot of focus around that. The other, I think, area that is relatively new, and it's the IT itself. So for example, one of the things that we're seeing is a lot of BI for IT. And BI for IT started as a passive thing, like monitoring and getting insights. New Relic, for example, is a good example for that. But it becomes more actionable as we're getting into something that is more software-based, and the entire data center is now software-driven. You could actually take insights and turn them into action, which means that we can reduce or almost eliminate all the human intervention in the process of how do you do 24/7 high availability, how do you deal with attacks, how do you deal with scaling, how do you deal with upgrades. A lot of the human processes can be completely automated as a result of that. And that's
so automating IT is a great
IT.
example, but it's
Exactly.
happening in other fields where you're automating it. So collecting all this data, quickly analyzing it, coming to a conclusion, then
exactly
automatically
exactly.
taking action based on the
Exactly.
data.
So it's not just generating insights, it's actually closing the loop and taking action upon those insights.
Right. There's another, besides New Relic, there's an Israeli company called Big Panda. It's kind of an early stage startup that's doing a lot of interesting stuff with data science and kind of DevOps automation using big data and that sort of thing.
So I'll talk about another industry, which is financial services. So whether you're in Europe or whether you're in the United States, or Singapore is leading the charge from a regulatory point of view out in Asia Pac, is that these institutions are under increased regulatory control, and what they need to be able to do is respond to the regulators' questions about business practices and the like much more in a timely manner than they had before. So they're requiring these financial services companies to keep a lot more data online, which they previously had on tape, right? And they're also requiring them to capture, right, more data for them to be able to, essentially look into from a regulatory point of view, right? All this from the financial services organizations just are an additional burden cost, right? So they're looking toward lower cost platforms in order to be able to service these requests, right? While at the same time, back to your point about this CX kind of function, right? So a lot of these financial institutions that we're working with are essentially going after the two use cases simultaneously with the same technology, right? So they're putting in these various systems in order to, one, satisfy the regulatory control, right? And two, to be able to, just exactly as you said, rather than having all their banking systems were built around the various banking products, right? The ATM systems, they have checking, maybe they have savings, they have insurance. I mean, not in the U.S., banks don't do insurance, but everywhere else in the world, they have insurance and the like. And what they're trying to do is to bring that information together. And the reason that's driving them is certainly to better target them. But what they're seeing this time in this era versus the data warehousing era was, in data warehousing era in the 95, companies were concerned about like competitors. Now they're concerned about unlike competitors, right? So the banks that have insurance, they're concerned, right, because we're working with other companies in the retail space that also bought insurance companies, and now what they're doing is they're calculating your risk based on the food that you buy, right? And we're working with automobile manufacturers to calculate your risk based on your driving habits, which are coming directly from the car. So the banks need to get this together because
I don't like that personally.
Yeah. Well, you can choose to. You can choose not. Yeah. Well, yeah. Neither does my wife, by the way. Yeah. Said, if you're going to get one of these tickets from the red light machines, at least you should smile so we get a nice photo. But, we're seeing that come forward as well, right? So I think that it's interesting if they can kind of combine two business cases together to kind of drive this action in the future, right? Because everyone that I talk to in nearly every industry, everyone's concerned about Google, right? Google will bash in and upset their market, right? Retailers are all concerned about Amazon, right, and what they're doing, right? And these systems in a large way are not to necessarily defend or go on the offense against a similar bank or insurance company, but rather to prevent some completely newcomer, right, that isn't burdened with the baggage of systems that they have or even their the intellectual burdens that they've had for the last 20 years, and to step in, essentially disintermediate either themselves from their customers, which is why everybody's freaked out about Apple Pay, right? Or to be able to disintermediate them completely out of business, like Amazon did to the book book industry.
Right.
So will I need to pay more insurance if I drink a lot of coffee?
Yeah, I don't know, but I would definitely be in that category. I could say that.
So we got a couple more minutes left. Maybe we'll take a couple of questions from the audience if we can get them. You can address them to somebody in particular in the panel
Just
or
do
to the
that,
panel in
and
general.
it's a mixed expertise of
Yeah. So does anybody have any questions for the panel? Yes, please.
I have two questions, and I'm happy for people to answer these in any order or whatever. One is about the harnessing of data from disparate silos and the extent to which you all face regulatory or other kinds of problems in those. I'm thinking of healthcare and financial services in particular. And the other one is, being a former math major, or I guess I was a data scientist, I'd love to hear about what you're actually seeing in machine learning. Is it really humans helping machines learn, or are machines getting smarter because the algorithms somehow actually learn? Thank you.
So I'll start with the first one because it's sort of right in the strike zone of what we do. Imperva comes from a world where we secure a lot of databases, relational databases usually that means, and there's all kinds of regulatory requirements on those. Almost all the use cases we see are people taking that regulated data from maybe a data warehouse, maybe other transaction systems, and putting it into usually Hadoop today. And usually the security person finds out about that after it's there. And it's not a real good scenario for them, especially if you're doing it because of a Singapore regulation. Maybe they're driving people to store more data online. Singapore is by far the strictest regulatory regime for financial services companies of anywhere. So the large banks are all saying, well, if we can do Singapore, Monetary Authority Singapore technology risk management, we can do everything. So they're trying to make all of their systems meet that one, and they're really struggling in big data because there really aren't that many technologies out there. I mean, my company's only recently come to market with one product, but you need a range of things to secure it. To speak to the second question, I would say it's a combination. In the security space, I can't speak to other spaces, the algorithms are getting better, but the companies that are successful here, they have a data scientist to do the math, and they have a security expert to then take that output and do something with it. So Exabeam would be a good example of that. They've got a team that does the data science that just basically does the math of the user behavior, and they have a different set of people that comes and looks at that and says, well, how can I use that for security value?
And in healthcare, really the utilization of healthcare data is governed by HIPAA, which is a Patient Data Privacy Act, essentially, that was amazingly enacted in 1996 and has not been really sufficiently updated given the burgeoning demands for healthcare information. And so when we work with a provider, we are a business associate, which means we take on a huge amount of risk for working with their data, and we ensure that there are appropriate firewalls and protection, and the data can only be used to help that provider in the improvement of quality. So we can't just go off and do interesting projects that aren't related to what's going to ultimately help those healthcare providers in the treatment of their patients. And I would expect there's a lot of activity on the legislative front to update HIPAA laws to be more in accordance with what actual utilization of the healthcare data now is starting to be on a much grander scale, and I would expect that to change over the next several years to reflect those demands.
And I think
Time for another question, or one last question, please, if there's another question. Yeah.
Yeah, I wanted to touch...
So let me just repeat the question.
Yeah,
in
sorry.
case, so the question was, so we talked a lot about the kind of the technologies and the data silos, et cetera, but this should also create a big change in business processes. And so the question is, what's your perspective on how it affects business
One of the
processes?
things that I think in the previous, we had a previous panel before and Wix, for example, described their organizational change in order that they could actually build the organization better to that. And it sounded to me very similar to the change that I've seen with IT for DevOps. So in DevOps, for example, we wanted to optimize for the speed in which we're releasing new features. And in order to do that, what we've done is we reorganized the structure of the organization and the IT into groups that works better and, for example, put much more responsibility into the developers to reduce a lot of the silos and cycles in that. With data scientists, and that touches also on the previous question, we have to get to that same type of consolidation in which the feedback loop, and that's become the most important thing from an algorithm perspective, how fast you could get the feedback loop that the data that comes in, you could actually make that insight or that insight. And in that case, the data scientist, for example, is not a group or a department. It's actually baked into the development group, into the application group, and it becomes part of that. Again, in order that we could iterate, and you'll always need to iterate. It's never like you have an algorithm that works and then humans just sit idle. It's the data changes, we become smarter, and we always have to iterate to see what type of insights we can actually get out of that. And in order, and from an organizational structure perspective, that means that we need to organize our organization not based on functions, but based on the speed of iteration, which means that we need to get this data scientist, for example, as part of the development group of the application, and the business guy would need to be part of that group as well. And we need to organize the organization based on those applications and not based on the functions of each individual.
I would build off of his analogy and say...
And after your answer, we're going to wrap it up. We're out of time.
If IT went to DevOps, that was really dev taking a much more active role in the IT infrastructure they were running on. I think here, business owners have to actually step up to owning the data in the same way. So instead of having IT own the data, the business has to start to own it, and that's a real big change because the business owners usually don't want to do that.
Thank you very much. All right, thank you, everybody. That's the end of our panel. Thanks for coming.